Welcome back. I'm happy we're at the end of option B, engineering physics, question 11, a short question. This question, too many things to look at. First, look at this thing. Determine the Q factor. So look it up from the data booklet. What is a Q factor? Q factor is energy stored over 2 pi energy dissipated. So now it's about gravitational potential energy, right? So energy stored is mg1, and then it's 2 pi, and the energy dissipated is mg 0.3, right? 0.3 is the drop of the height, okay? So it is mg 0.3. And then use the calculation and you'll find the Q factor is, try to pause the video and work on it. Yes, you got it. Okay, now checking time is 0.5 V, okay? Okay, all are two significant, so yours should be two significant too. Okay, no, next one, okay? Part B, and yes, the period of the swing is 3 cm, 3 seconds, okay? So draw the variation of the time and height for the first two complete oscillations. So first is 1, and then become 0.7. And the second oscillation is goes to, remember, drop by the same ratio from 1 to 0.7. The ratio is 0.7, right? And then to 0.7 square. So it should be 0.49. So nearly 0.5 for the next period. And the oscillation, so up, down, and up. So down is here, down is here, approximately. Okay, so up, down, up, down. If you mark all these points, okay, it will be excellent. Look at here, two complete oscillation, 1, 2. So enough, okay? Excellent. So last one, estimate the height reached by the swing after 15 seconds. One period is 5, so 15 seconds is 5 period. Each time drop by a factor of 0.7, so become 1.0 times 0.7 to the power of 5. So calculation time again. Pause the video, work on it. Yes, come back. Now it's a tracking time. Remember, same figure, so it's 0.17 meter to figure. You got it? Well done. If we do option B, then paper 3 is finished. Well done. If you like our channel, remember, like and subscribe. We need your support. Thank you.